welcome to stream number 3. I'm Maria Rosaria Re, and I'm a research fellow at the Department of Education of University Roma Tre, Italy. I'm here to welcome you and introduce the session. The Learning Ideas Conference brings together researchers and practitioners from around the world to discuss, innovate, and create. It's the place where the international community gathers to find new paths, solutions, and innovations in learning and technology for the workplace and higher education. Today's session name is Stream 3, and I'm happy to kick it off to the first presenter of the session, Professor Dr. Christian Andreas Schumann from the University of Applied Science from Swisswag in Saxony, Germany. I kindly ask Professor Schumann to share his screen. The presentation of Professor Schumann is entitled "You Bring to the Power of X Higher Education, a multidimensional overlay of hybrid forms of learning and teaching." Professor Christian Andreas Schumann is full professor of business informatics at the West Saxon University of Zwickau. His research focuses on the complex design of business systems as well as factoring and production informatics. He cooperates with the UNESCO office and the Arab Academy of Science in Beirut. Now we are using the Q&A box for questions and the chat for technical issues, so please post your questions in the Q&A box and we will respond to them at the end of the presentation. I'd like to remind you, Professor, that your presentation will last about 25 minutes and we will have 5 or 10 minutes more for questions. So the floor is yours, Professor.
So now it should work. So it's audio is available. Sorry for that. Thank you very much for the kind introduction. I would say for Asia, good evening, for Europe, good afternoon, and for the United States or for America, good morning. Education, also other kinds of applications, such as industry, economics, and so on. The agenda for my short presentation is the growing complexity and diversity. Second one is the focus on order in higher education and multidimensionality. And at last but not least, it's quite clear we have to say something about hybridism as a complementary learning theory, according to the topic of my paper. First, education is the basis for social development and one of the most complex applications as well. We have recently the situations that we going from the knowledge society to the network society, so we have a combination of both sides. And the motivation drivers are the development of knowledge in different kinds of relations, from retrieving knowledge up to the exchange of knowledge, sharing knowledge, all is included. But what is behind this idea and these networks? We have the networks consisting of knowledge nodes, knowledge flows. And we have to follow a special line or direction or objective. We have so-called knowledge goals, scientific-oriented, business scientific-oriented, and business-oriented. We developed some years ago a special kind of knowledge transfer theory. We say, okay, we have different kinds of knowledge nodes, and the one option is that the knowledge nodes are in a finding procedure, then we coupling, then we can substitution. So we have a dynamic behavior of knowledge nodes coming together and or divided or substitute, eliminated, or what else. Or the second option is we find the knowledge nodes and then we have the opportunity to coupling, merging, unifying, and to build up, to design a larger area or a larger knowledge node for the application. On the right-hand side, there is a next step of the idea that we come from a knowledge node knowledge nodes are coming together in organizational group, and then the next step is organizational network. So we have a step-by-step growing potential of knowledge. We can use this explicit knowledge for different kinds of applications in a very huge manner at the end. So one of the applications in this field, we had a project, a large project last year, some years ago, dealing with so-called competence cells in manufacturing, production, and industrial and environments. The starting point is we're coming from input, we have output, and inside we have different kinds of competences, resources, and functions. And it's characterized by structure and dimensions. And behind this, we have these applications like business intelligence, data analytics, different kinds of applications, and also the knowledge and information management in the companies or in the organizations in general. And it's possible to combine these different kinds of competence cells with different kinds of functions, different kinds of processes, so we can develop a network of competence coming from consumer needs to the consumer knowledge. And we have such a kind of knowledge transfer process in application areas. Additional to this situation, we have to remember that we have for the learning environments for education also the impact of AI, very complex impact of AI. And we have now the situation that we have different kinds of application areas from informatics and engineering, cybernetics and logic, biology, and so on, up to the mathematics, statistics. And so we have a wide range of transdisciplinary, interdisciplinary applications. And we have, in addition, in learning and education training some kinds of additional complexity concerning the AI applications. What is the response? Our response to this kind of development in higher education? We try to combine different kinds of education, like such as non-academic education, non-formal education with formal education. We combine recognition and different kinds of upgrading of education training programs. We have to look for different kinds of interfaces from the professional learning, non-academic professional learning, to the more academic learning. We have now integrated study programs beginning with professional programs in companies, going up to university, bachelor, master programs, up to PhD, or going outside to the practical work. And we have also the situation that many of our former students come back in order to realize further education in our university or in our university networks in cooperation with some private suppliers, education suppliers. That's why, because we are a relatively small university with about 4,000 students, we are normally specialized to be active in our region. But now we're going more and more in a network society, and that's why we are also part of future networks. I'm, for instance, responsible for one of the largest Chinese-German projects in higher education. It's the so-called Chinese-German University of Applied Sciences, with about 35 universities from Germany and Switzerland. And we look always for one top university in another country. And recently, we have a cooperation with the Tongji University since 2004 in four study programs. And we have double degree programs, and we are very successful in this way. We have more than 1,500 about alumni already in this area, high qualified alumni for our organizations in Germany as well in China. The next step was to go to Mexico. We have a cooperation with a network with the Tec de Monterrey, and now, beginning in this year, we started a cooperation in India. So the main objective and the main strategy is to have a large network. Our network has about 200,000 students, and so we can go outside and have a cooperation with other huge educational organizations in order to be successful in the international and global way. For this, we need this quite clear different kinds of applications, different kinds of study programs, different kinds of learning theories, learning practices, and so on. And dimensionalization helps to create order in the chaotic procedures of network-based learning. This is our idea, and I think it's a general way in the world to do so. To explain it using an example, we had the task to develop a new study program, Industry 4.0, in cooperation with the Tongji University, dealing with the area of cyber-physical systems, especially in the field of industrial applications. The study program is called Engineering Management. So we developed 2 dimensions. One dimension is divided into 4 sub-dimensions: system, model, technology, application. And the other dimension, main dimension, is divided in 5 sub-dimensions: business management, ICT, production logistics, safety. Safety is a very essential thing recently in the world. That's why we use our own sub-dimension for safety. And last but not least, engineering. And on this basis, we can organize we can think about the different kinds of possible learning paths. And so here's only one example how we can vary different kinds of opportunities in such a learning path for students. And so you can plan different kinds of opportunities to go through this offer, and then you can see what is the right general way for a larger group to be successful with a special certification at the end of the program. And here's another opportunity. We can also use the morphology for searching special content, so that we can also derive from the system, for instance, special kinds of certificates for our further education programs. In the background, it's more and more mathematics and informatics background. We have the semantic network architecture, so we can each topic combine with other topics and store the relations in a semantic network. How we can use object orientation for finding the dimensions. Dimensions are very essential because dimensions can be hybrid, and that's why we look for the right dimensions in order to have the dimensions, and the dimensions we can bring in a hybrid state. Object orientation analysis means identify the dimension, ordering the dimension, assigning attributes, assigning behavior, and describing interaction of the dimensions. Is a first part. And then if you have the results, then you can start the object-oriented design. This means we have to look for classes, and classes are also similar to dimensions. Restructuring the classes, implementing attributes of the dimensions, implementing behavior of dimensions due to the first step of analyzing the system. And then we have to implement the control and implement the associations. The implementing of the control is so essential because we have the problem of a chaotic system in learning in networks. Everybody can do what he wants, and that's why you have no control over the learning procedures. And coming back to a better and part partly controlled system, it's better to have an overview by dimensions and also the overview by hybrid states of the dimensions. Here, one opportunity to have an architectural structure of dimensions is in this example was described in this example. Self-learning, for instance, ebooks, web-based training, chatbots, learning nuggets, and so on. Teacher-centered learning as the second main dimension, online tutoring, coaching, e-assessment, all such things. Group-centered learning, interactive gaming, online bar camps, internet collaboration, and so on. Group-centered communication, all what is essential for social networks, chats, newsgroups, and so on. And last but not least, we have very interesting universal tools applied in different kinds of study offers, virtual reality, augmented reality, MOOCs, and so on. So it's only one example. The theory is so general and unified that we can use it in different kinds of relation from different kinds of viewpoints. One example we presented already in another conference is hybridized states in STEM education, science, technology, engineering, and management. There we have different kinds of work packages, and we can also transform the work package if we want in dimensions, and then we have dimension with three opportunities of state: high, low, and medium. And then we can organize the degree of digitalization, possible AI impact, and existing STEAM reference, in this case, in three stadi concerning the different kinds of dimensions. Last but not least, I should explain something concerning hybridization is the key for controlled response. Hybridism has the potential as complementary learning theory. We finished a project dealing with combining all different kinds of opportunities for coming from the monolithic content structures of the past. We can granularize the systems the documents to have small learning units. This means content structuring. Then we can store it into semantic networks, semantic structuring. And from this semantic network, from this semantic database, we can realize the course generation. And we can put different kinds of sub volume of the stored knowledge in order to be target group oriented, and we can individualize the programs. What are in this case the dimensions were level of difficulty, methodology, and distribution. And we have for each state we have the opportunity to use three different kinds of hybrid situations: beginners, advanced, expert, exercise course, lecture notes, presentation, and for distribution, print version, PC, or mobile device. In the abstract sense, we have different kinds of hybrid forms. We can start with a one-dimensional line. We can go in the next step to a two-dimensional area. Then we have the three-dimensional cube. This is an example for the three-dimensional cube already, not only one or two-dimensional, three-dimensional cube. And last but not least, we can come to a multi-dimensional space, a mixed state composed of different states and different things. So it's a normally very simple approach, coming from one dimension, going up to X dimensions for a multi-dimensional space. The relation to learning theories is that we have in the past the behaviorism, cognitivism, constructivism, instructionism, and the latest learning theory was the connectivism developed by Siemens in about 2005. and you can see there a correlation between connectivism and network of knowledge. So there are some common characteristics for both sides, because at the end, all learning is directed to the change of knowledge, the change of behavior. So that's why you have a strong link, strong relation to the knowledge management and knowledge development. But we think we shouldn't forget now the machine learning as a next step, and it will be very interesting how will be the combination of machine learning and the other learning theories in the future. But our focus is now to hybridism, and we had a project where we used the different kinds of opportunities to develop a special kind of knowledge and database services, and it is described again in the semantic network, and then we have for the users the knowledge navigation and the knowledge access. So from the user side, you come from knowledge navigation and access, use in the background the semantic description of content, and then this part of your individual interest will be found in the knowledge and database services. The challenge of learning in networks today is they are global, they are dynamic, they are random, uncontrolled, unverified, unethical, sometimes obsolete, disruptive, and so on, heterogeneous. And that's why we should try to come to a more and better controlled and organized system, so that we have really understanding of what was the beginning, how we can realize the learning, and especially the behavior change and the acquisition of knowledge, and what is the result, so that we have a good overview. It will be more transparent to come to a new kind of learning. In this sense, hybridism as a learning theory approaches learning from a holistic perspective, from one-dimensional to hyperspace, in which each dimension can be hybrid. In essence, all aspects of learning can be viewed as hybrid dimensions that can be conceived, modeled, and optimized as hybrid systems. The advantage is higher transparency, better controllability, and optimization of learning in complex learning environments and in complex learning situations. And the question, the last slide, is related to the question, hybridism as a meta theory, because we can use the hybrid approach for each kind of learning theory, other learning theory. I try to characterize it in a very simple way. I describe one opportunity of one special dimension for each learning theory, for instance, machine learning, or start with the first one, with behaviorism, use of stimuli, cognitivism, use of models, constructivism, active design of subjective images, and so on. And on the right-hand side, you can see we can use, or we can find a certain point of hybrid between 0 and 1, or 0% and 100%. So you can have the opportunity. You have the opportunity to change the hybrid state of each dimension, and though you have really again an application of this hybridism as a theoretical approach. This was all what I have to report. Thank you very much for your attention, and thank you for your attention again. One old Chinese proverb, still when the wind of change blows, some build walls and the other will not. Thank you very much.
Thanks to you, Professor. Thank you also for all the attendances and this particular and very interesting presentation. So while probably attendances should insert their questions in the Q&A box, I will ask you a personal question, if I can. I'm so much interested in the object-based design, thinking about higher education institution. So Taking into consideration this particular design methodology, what strengths and weaknesses do you think should be noticed by higher education institutions that are thinking to use object design methodology for their course?
No, I'm from business informatics, so I applied informatics. That's why it's my nature to use such things. But it's true, it's not so easy to use it in higher education for all institutions, for huge organizations. So the strength is that we have a good structuring, really good architecture, and that's why I higher transparency in the systems. And it's better for planning, for organizing, developing the content, methodology, and all those things. So it's easier to work with a very good structured and systematical approach. The weakness is that we have borders, we have limits in this area because of the complexity. It's not so easy to model all different kinds of characteristics. That's why sometimes it's better to have a rough modeling, because on the other hand, you have billions of different kinds of characteristic attributes and so on. That's why you can also stay in a certain space for developing such things with object orientation. And last but not least, and it's really a challenge to educate and to train your own people, your own staff to come to this thinking. That's why I think design thinking is so essential for each training program, because it's the first step to come to a general understanding how we should think in order to be able to use object-oriented theory.
Exactly, it's a very key point now for the entire higher education system. So thank you for your answer. I don't know if there are other answers, maybe I not only in the app. So the last question for you, for my side, is how machine learning can support hybridism in higher education, because in the last maybe slides of your presentation, where there is a particular focus on individualization of learning path, taking into consideration the learning context, the machine learning is not so used, if I remember correctly. So what do you think about the relation of the use of machine learning in this hybrid context, so innovative?
Hybrid learning and machine learning is already part of the engineering education, or it's the first education in engineering, for instance. I remember some so-called sub-board of the Society of German Engineers for engineering education. And I'm also in the board for digital transformation of our organization. We are a huge organization with about 140,000 members in different kinds of areas of engineering management. And in this relation, we recently discussed the opportunities to extend the application of deep learning, for instance, as one part of the machine learning opportunities. And what is very interesting, but is still future, how we can combine in the future and match the learning of the artificial devices and the human beings. And I think we are already on the way, because about 15 years ago, we had a large project in the VW company, especially for diagnostic in production areas. And in this case, we already used expert systems in order to support the operators. And already 10 or 20 years ago, the operators were supported by artificial intelligence systems in these special application areas. So it's not really new, but what is new is that artificial intelligence is now available for the whole mankind, for everybody. Normally the access is possible. But now the question is how user-friendly we can develop all things so that we have really the chance for everybody to use the opportunities and the advantages of AI.
A really good challenge. So thank you very much, Professor, to join and present your work in this learning conference.